situations in inferential statistics where a margin of error is preset, and we need to determine how many we need in our sample in order to have the level of confidence that in making a confidence interval with that preset margin of error. Now, these sample size questions can actually be done in the work with several different parameters, whether it's the population parameter, the population proportion parameter where we have a pre-estimate for p-hat, or the population proportion without a pre-estimate for p-hat, or the population mean, or even the population variance or standard deviation. So one of the first things with these sample size questions, once you recognize that it is a sample size question, is to also determine which parameter you're working with so you know which formula to use or which table to reference. I'm going to show you an example of finding the sample size in a question that's asking you to do the process with a population mean in this video. So here we have a random sample of school teachers show the standard deviation of years of teaching experience to be 5.3 years. How many teachers, so how many, it's a sample size type questions, should be in the sample to be 95% sure that the sample mean, so it's a sample size about the mean, is within 6 months of the population mean. So this part's telling me it's mean, and then how many is telling me it's a sample size question. The formula for finding the sample size for a population mean, if you have the specific margin of error fixed, is n is equal to z sub alpha over 2 times s divided by e quantity squared. And with this, z sub alpha over 2 is our critical values from the inverse norm or the table. S is the sample standard deviation, or if you have a population standard deviation, you could use that as well. And E is your margin of error. So let's go ahead and work that through with this example. I need to first find my z sub alpha over 2. So remember, for z sub alpha over 2, that's where we have the percent in the middle of this sketch, and I know that because also they're doing the work with like your confidence intervals. So I have 0.95 in the middle. Now the entire area caught under the curve over the number line is 1. And we subtract the area we already know about from 1, and we see that there's a 0.05 area left to be shared amongst these two tails. That's your alpha. Now we want alpha over 2 to find out how much area is in each tail. So when I take the 0.05 and I divide by 2, I get 0.025. And that's the amount of area in each tail. Now I want the z sub alpha over 2. So I want the z-score for which that is the area that we would have. And remember, when you have the area and you want the z-score, that's when you use the inverse norm on a TI-83 or TI-84 calculator, or you can look up the table using that information backwards on a table. Now on the TI-83 or 84 calculator, you're going to push the second button, and then you're going to push the button that says VARS on the top. It's really close to the clear button. Above that on the board of the calculator, it says DISTR for distributions. And that's where you go to find the normal CDF, the inverse norm, the normal PDF, or binomial PDF, binomial CDF, all of those. So push second and the VARS button to get to the distribution. Go down to find the inverse norm, because we have the area and we want the z-score back. And the input is been programmed by the software engineers to be an entry of area entirely left of whatever cutoff you're interested in. We can figure out that number in one of two ways. One way is the entire area is 1. So 1 subtract the 0.025 is a 0.975. Or you could say the entire area left of that cutoff is 0.95 plus 0.025, which again is still the 0.975. It's also the z critical value. So remember, for the z critical value, the mean is 0 and the standard deviation is 1. And when you calculate that, you're going to get a 1.96. So that's what our z sub alpha over 2 is. And so that's what we're going to put in this formula for the z sub alpha over 2. Now that gets multiplied to whatever our standard deviation is. And our standard deviation is 5.3 years. And we're looking at the expression in years. So we're going to multiply that by 5.3. And E is the margin of error. When you're doing these problems for sample size, usually if you look for the word within or some similar wording to that, it's the number that follows the word within that is your E. Now, this says within 6 months. These units don't match. So we have to think, well, if I have my standard deviation in years, then I want to change this 6 months to what portion of a year that represents. So 6 months is 1/2 of a year, so I'm actually going to put a 0.5 in for the E for this problem. Now when I go through and I run and calculate that, I get n is equal to 431.642. But for sample size questions, you're telling somebody how many they need to go out and sample. So they need a whole number in order to know how many to go out and sample. And we want to make sure that we meet the criteria of the problem. So these you always round up. So don't round nearest, round up. The 431.642 would, in normal rounding, go to 432. So that's not an issue with this particular problem. However, if this would have been another sample size question and it would have said maybe 431.004, I still would go to 432. Because if you round down, you're not meeting the criteria that they're asking you to do with your margin of error. So always round these up. So here, then my sample size is 432, the answer. One last comment is if it tells you how many they pre-sample in order to get a sample standard deviation to get really how many they need. So that means that you're still going to go through this and find the actual n that's needed. And you would only need to get your sample size minus how much information you already have to get the rest of them that you need to meet that criteria.